Okay, so lesson two on methods, I wanted to start talking about parameters. Last lesson, we just had a general introduction to what a method is, but method parameters allow you to take in values to your method and change the way that it works. So it's a lot more powerful than not accepting parameters and just having empty curly brackets at the end of your method. So if it's something that's useful, you can add these parameters to make your method more flexible and work in different cases. So the way methods work is they're kind of like a local variable to the method. And once the method is done, those variables disappear, which is nice. It frees up memory. They don't interfere with other things in your program. So uh, yeah, so it's very handy. Now, data, there's a terminology that's here. Data passed to a method, those things are called arguments, whereas this here, when you define the value, this is considered to be a parameter. So I kind of use parameter more loosely. I'm not too worried about the terminology, but technically the value, the number, or the thing you pass in is actually called an argument. And these things here that you define in the header of your method are called the parameters. So in this case, it has one parameter called length, the drawbar method. Now, let's take a look at drawbar in Eclipse. So if I flip over to Eclipse here, so here's my example. Actually, let's go to the first example. So to make a simple method here that just takes one parameter, so here I called it len. This is a public method because it's available everywhere. It's not private. Static because it belongs to the class. Void because it doesn't give me back or calculate a value and return it to me. It's doing is drawing on the screen, so it's void. The name begins with a lowercase d because it's a method. That's the naming convention. Capital B for the next word. And in the round brackets now I'm giving it an integer called len. Now len gets initialized when I call it. So here on this, in my main method, I'm calling drawbar with a 5. So basically what that's doing is it's initializing len temporarily to the number 5. And then this for loop is going to go loop up len number of times, and it's going to print an asterisk. So that's going to stay on the same line because it's a print command. When it's done, I'm going to do a print line to make it go to a new line afterwards. So if I run this, I've called it with a 5, then I changed it to a 2 and then to an 8. So that's why the first time the length of the bar is 5 long, then 2, then 8. This could almost be used for something like a bar graph, sideways bar graph, I guess. So you can see how by calling the method with different values or arguments being passed, this parameter gets initialized to different numbers. It loops a different number of times depending on what the parameter's value is. So that, I'll just comment this out by doing a control slash. And now that we've seen it called with different values manually, like literal numbers, now I'm going to just control slash this, and we'll look at it. It's going to draw a right angle triangle. It's going to loop. This for loop goes from 1 to 5 inclusive, and it's going to change the value of what this row variable is. So this is a variable that's local to the for loop. Once the for loop's over, it doesn't know what row is, which is another reason that it's great to have local variables. It's going to pass that number. So the first time it's going to pass drawbar a 1, then a 2, then a 3, then a 4, then a 5. So when I run this, it's going to produce a bit of a triangle here, a right angle triangle. So I'll try to make that a little bit more visible. So you can see it's done its job to draw bars of different lengths. So I'm kind of using this method as a helper. It reduces the cognitive load or the burden on me, and it abstracts that task of drawing a bar to the method. And I can just call it now in a loop and go, oh, I know the first time it's going to draw length 1, then 2, then 3, then 4, then 5. That's going to make a triangle. So that's kind of a basic demo of taking a parameter and making the method work differently each time. The next concept that I wanted to take a look at is, let's just flip back to the, yeah, so that's kind of this first slide. I want to talk about method overloading. So method overloading is when one method has the same name as another method in the class, and you might wonder, how can it know which one it's going to call? Well, they would be different in terms of the types or the order of those parameters, the number of parameters, and then it would match the one that it sees that has the same parameters. So going back to Eclipse here, example 2, here we're having, if we look down here, we've got drawbar here, and we've got another drawbar. Very confusing. So how's the program going to know when it calls drawbar here? Well, in this case, it knows, okay, I'm going to call drawbar with 2 parameters. One looks like it's h is a number, an integer, right? So h is an integer, so it's going to call the method that matches an integer parameter first, followed by that's a char because it's in single quotes. So it looks, oh, here we go, an int followed by a char. The order, of course, matters. I can't call it in the reverse order with a char and then an int because it wouldn't match up. They have to match up the order and the types. So it's going to pass it, the first time through, it's going to pass it h is 1, and it's going to pass it this ampersand symbol, and it's going to take those initial values of 1 and the ampersand, and it's going to loop a certain number of times and print that symbol that was given. So in this case, like the comment here says, I'm overloading my method to allow the user to specify the character to draw, whereas before it was always an asterisk. So, I could ask the user what character they wanted to work with, and that would help them to draw a little differently each time. Okay, so while my computer crashes there and works on that, let's flip back, pretend that didn't happen. And we're going to look at, here's the signature. It's just slightly different than the one I showed you. This one takes a string. So you can see the types could be any, it doesn't have to be just primitive data types. It could be an object. And by the way, you have to separate them by commas. You can have as many as you want. And the order matters. And yeah. You might have noticed in the program, I had a bit of a different documentation style going on there. It was /** and then //. Before, previously, we know we can make comments by doing // or if it's a one-line thing, we can do /* and // if we want to do a multi-line comment. But these comments are called documentation comments. They have a specific purpose to them. So I'm going to show you that. The method documentation should just explain what's going to happen in your method, what task it's performing, and I'll show you. There's a couple other things you can add in, but it must definitely appear exactly right above the method header. So you can't put it anywhere you want. It has to be right above, directly above the method header, and it has to be /** and all the comments you want, and then // to switch it off. So yeah, we will talk about what these preconditions and postconditions are. Let's go back to Eclipse. Oh, it's happier now. That's good. So you can see here, this is my method documentation style. Eclipse, it turns it blue instead of, I think it was green before. This one's green. That's just a regular comment. So if I wanted to comment this one down here, I could say /* and hit enter. And it kind of helps me, it builds, it knows I already have a length parameter. So it says I have this len parameter, and I can describe, this is the length of the bar, something like that. So the precondition would be that it has to be a positive, len has to be positive. So I could put precondition. So in order for this to really work, len must be greater than, I suppose it could be equal to 0 as well. That would be valid, but it can't be negative or else it's not going to work. So, by the way, while I'm here, I'll just show another thing, and then I'll continue with this method documentation. But in this program drawbar, I can actually, since this one is so similar to the other one, I could actually have this one, the more generic one or general one, call a more specific one, and it'll save me some code. So actually I could get rid of all this, get rid of this, and I could just do this. I could have it call my other drawbar method with the len that I was given here as a parameter. It passes that number along to here. And then it specifies an asterisk as sort of the default character that I want to draw using, right? So it specifies symbol to be equal to the asterisk, and then it runs and does its job. So now I don't need all those lines of code. I can just have one that passes here, but specifies sort of like a default value for the symbol. And that should, oh, did I call it? Yeah, I think it did. No. Let me control/ this. I'll just call it drawbar. So, I was calling the other one drawbar with just a 4. It's going to jump down, and it's going to do it in asterisk, which is my default symbol. And I don't know why Eclipse is working so slowly. So while it's thinking about that, I will talk about back to the, oh yeah, there we go, drawbar for length 4 of asterisk. So what I wanted to jump back to though was why do we need these method documentations, these blue comments here? What's the point of them? So normally when you look up string class or random class or any other class that somebody's made, you want to know what the name of their method is and what parameters it takes. Like what information do you need to give it for it to do its job? So programmers write method documentation to allow other people to know how to use their methods. So to generate these things, and usually for final projects, I get students to do this. I can go to project. It's a little different in other IDEs like IntelliJ and other things, but there should be a generate JavaDoc feature. So currently I'm really just, I don't want to generate it for all my classes. At the moment, I'm just going to do it for this one example. I have to specify where the JavaDoc command is, and I have to specify where I want to put all the JavaDoc that's generated. Usually put a directory called doc, and then I just run it. It's going to do a bunch of stuff in the console here, a bit of red, but that's okay. And it made this doc folder. And if I go in the doc folder, I can go to the index.html. That's my main, that's my home page, so to speak, for my package called demo, because this is in the demo package. If I had multiple classes, they'd be listed there. I can click on it, and you can see it's generated automatically this whole web page, which I can look at it in a browser, of course, because it's an HTML file. And if I had have commented what the class did or what other things did, I would have more documentation here. But really, all I did was, if you remember, I put this here, and it tells other programmers what the name of my method is, that it's a void, that it's static, that it takes a parameter called len, and and then it shows my overloaded method with the comment that I put there. It just basically picks that out of my /** documentation and puts it into HTML and makes it look super fancy and professional. And when you look up other people's code, it'll look exactly like yours. So this is called API documentation. If you look up the API documentation for string class, you'll see something that looks similar to this. So I think that's almost it. Yeah, the pre and post conditions. Preconditions are what must be true before in order for your method to work properly. I would say that's pretty important. If there is some precondition, you should list it. Post condition states what must be true after it's executed and worked properly. It doesn't really state what, like how you solve the problem or how you did it. It just says what should be true after. And they shouldn't state the facts that the compiler will verify, like that it's an integer going in or a double or whatever, right? So just more for people to look at and know how to use your method. So here's just one example I came across the other day. The AP exam's coming up at the end of this week, and a student wanted to know how to write this method. So I was helping them out with it, and it had a good example of precondition in it. So in order for this is-valid method to work with some number, what must be true, according to the precondition, is that this number, this integer, has to have between 2 and 7 digits. Otherwise, it's not a valid, checksum, like an ISBN number, that kind of thing. And the number has to be a positive number. So those are two preconditions that must be true for this thing to work. If the user gives it bad data, it's not your fault. It'll crash. That's fine. So on the AP exam, you don't have to do an if statement to check if the number is positive, like greater than or equal to 0, because that's part of the stated precondition. So it means inside your method, you don't need to handle it. Yeah, so that's what a precondition is. And I think that's enough. I can talk about return types in the lesson 3, but yeah, that's enough information for now.